Good morning, everyone. Let us now see about what is an amplifier. An amplifier is an electronic circuit which is used to increase the signal strength. So, if the strength of the signal is very weak, we are able to amplify the signal by sending the signal into an amplifier. So, what is a feedback amplifier? So, we are able to strengthen the output of the signal by using this feedback. So part of the output is being sampled or given back to the input of the amplifier. So this part of the output which is fed back to the input is called feedback amplifier. So hence the input we have two signals, input signal, part of the output signal which is fed back to the input. What are the different types of feedback amplifier? We have positive feedback and we have negative feedback amplifier. So what is the positive feedback? So when the amplifier input signal and the feedback signal, when they are in phase, so when they are same, they do not differ in phase, then it is called positive feedback amplifier. What is negative feedback? When the input signal, amplifier input signal and the feedback signal, when both these are out of phase, that is, they are at a phase difference of 180 degree, then it is called negative feedback amplifier. This is the general block diagram of the basic feedback network. So we have a signal source, we have a mixer network which combines or mixes the input signal with the feedback signal. Both the signals are being sent to the amplifier and the amplifier output is sampled. Part of the sample is being sent as a feedback and the remaining we get as the output. So here in this network it has three networks. So in this block diagram, I have three networks. One will be the mixer network, other will be the feedback network, and here we have the sampling network. So we can see the operation of each network. What is a mixer network? So mixer network is used to combine or mix the input signal with the feedback signal and it produces an amplified signal. So here in the mixer we have voltage mixing, or it is also called series mixing, or it is also called loop mixing. And the other classification is current mixing, shunt mixing or node mixing. So first voltage or series mixing. So here the voltage parameter is mixed by connecting the feedback network in a series manner. How the current is being mixed? So the current or shunt mixing. So it is mixed by the feedback network in parallel with the mixer network. So it is connected in parallel. Sampling network. So here in the sampling we have voltage or node or shunt sampling or current or loop or series sampling. So in the sampling too, we have node sampling or we have voltage sampling and we have current sampling. So if we consider the first type, voltage or node sampling. So the voltage is sampled by connecting the feedback network in shunt across the output. And the current sampling is sampled by connecting the feedback network in series with the output. So if you note properly, the voltage sampling uses the connection shunt in the sampler and uses connection series in the mixing. What is the feedback network? Feedback network can be constructed using resistors, capacitors, inductor, and we have a feedback factor or the feedback ratio beta which lies between 0 and 1. So when calculating the gain of the negative feedback, So consider the general block diagram. We have signal source and consider Xx. It can be a parameter voltage or it can be a current. And we have the amplifier. Before the amplifier we have a mixer. So this is the difference signal. So one signal coming from the source Xs and the other signal coming from the feedback Xf. Since it is a negative feedback, I use here negative sign. Output of the amplifier, let me consider it as X naught is A into Xi. What is A? A is the gain, output by input, X naught by Xi. So part of the output X naught is given as the feedback. So here the feedback ratio beta is given as output to input. What is the output of this feedback is given as Xf. What is the input for this feedback X naught? So Xf is equal to beta into X naught. So Xs is the source signal, Xd is the difference signal, Xi is the amplifier input signal, X naught is the amplifier output, and Xf is the feedback signal. What is A? The transfer gain of the amplifier without feedback, or it is the open loop gain. What is AF? It is the transfer gain of the amplifier with feedback, or it is a closed loop gain with the feedback. And what is the return ratio? So the difference signal XD is multiplied by A and is multiplied by beta when transmission through the feedback network and is multiplied by -1. So considering here, so the signal, it is multiplied by A, here it is multiplied by beta, and again it is multiplied by -1. So in this whole loop, we get the value minus A beta, that is the loop gain. So loop gain is the product minus A beta. So now consider open loop gain A without using feedback, X naught by Xi. So without using a feedback, my output is X naught, input is Xi. By using a feedback, what is my output? Output is X naught, input is X. So A value considered as X naught by Xi, and closed loop gain with the feedback AF considered it as X naught by Xs. So the amplifier input signal, what is Xi? It is source signal minus feedback signal. And what is source signal? Xs is Xi plus Xf. And the feedback with gain X naught, consider now X instead of Xs, consider Xi plus Xf. Now divide numerator and denominator by Xi. What is X naught by Xi? X naught by Xi is A, capital A. So replace X naught by Xi by A. This Xi will be getting cancelled. You get the value 1. And here you do not know what is Xf by Xi. So I multiply and divide by X naught. So now what is X naught by Xi? It is A. And what is Xf by X naught? Output is from the feedback, input is from the output. So this we can replace it as beta. Now this is the gain, closed loop gain, or the gain with the feedback for negative amplifier. So here we get AF as A by 1 plus beta A. Similarly, if I substitute the value for positive feedback amplifier, what is positive feedback? So here, if I give a positive here, so what will be my difference signal? Xs plus Xf. So if I substitute here for positive feedback, so for the positive feedback, I get the value of closed loop gain as AF is equal to A by 1 minus beta A for positive feedback, and for the negative feedback I get A by 1 plus beta A. So note down the value, the operator here. For the negative feedback, I get positive sign, and for the positive feedback, I get a negative sign here. So what are the various applications for this positive feedback? So for this positive feedback, I can go on for oscillators. So we can see about that in detail. Thank you.